Everyone, today I want us to learn about 3-bit up counter. After this 3-bit up counter, we will also look at 3-bit down counter. With 3-bit up counter using the D flip-flop, you would need 3 D flip-flops as I've got here that you can see. You need 3 of the D flip-flops so that will give you 3 inputs using the Qs as our inputs. You will also need what I've highlighted here, that is the 7-segment display. You would need a clock, and if you also require, or if you also want, you can add these LEDs to it. So I've added 3 LEDs and then I have my D flip-flops. I have my 7-segment display and I have my clock. So what we have to do is with the up counter, you connect the clock to the first clock here, and then you connect the NOT Q of the first flip-flop on your left, the stream left, to the next clock, and then this NOT Q here to the next one here. Then what you have to do is to connect the D to the NOT Q and the next D of the next flip-flop to the NOT Q there. So, and then this flip-flop, the last one on my extreme right, I will connect the D to the NOT Q of it. So this leaves us with the Qs of each of the flip-flops, which is going to serve as our input to the 7-segment display. So what I'm going to do is I have my 7-segment display here. So I will connect, first of all, let me put it where you can see. So I'll connect the first pin to the first Q here, then this pin to that one here, and the third pin to this one here. So this is nicely connected. I will place it there so that we can see what's going on. Let me just zoom in a bit so that you can see. What I'm going to do is to connect this. I will connect the LEDs. I'll connect each of the LEDs to the Qs as well. So this first one to this Q here, and then this LED, the green one, so the yellow one to the second Q here, then the green to the last one here. It doesn't matter which color you connect to any of the Qs there, but I've just done it that way. Now we can simulate and see how this circuit is going to behave like. And please remember that because we have 3 outputs, 3 inputs, that is one from the first flip-flop, and then the second output, the second Q from the second flip-flop, and then the third flip-flop has also 1 Q there. So all those Qs there makes our 3 inputs, and because we have 3 inputs, our outputs are going to be 8. That is 2 to the power 3 is 8, and this is using binary. So 2 to the power 3 will give us 8 counts there, counting from 0 to 7. So let's simulate and see. So 1, 2, 3, 4, 5, 6, 7. So you can see it clearly. 2, 3, 4, 5, 6, 7, and then it comes to 0, and then it goes up again until 7, and then after 7 it all comes to 0 again, and the count starts. So this is how you can connect, or you can build your own 3-bit up counter that will count from 0 up to 7, which is 8 counts. Thank you very much for watching, and expect more videos from me.